Good morning, guys. Of grade 11 today, inshallah, we're going to continue section 2 of chapter 6. We're still talking about covalent bonding and molecular compounds. So last time we started to explain, the covalent bond and how the covalent bond is formed between two similar atoms or two in a molecule, and then or even two different atoms in a molecular compound. And then we start to talk about how could we express the orientation of electrons in the covalent bond by something called the dot notation. And we said that dot notation is kind of electron configuration that represent the electron in the utmost energy level. So for example, let's remember here we said that one. For example, we need to make the electron. We need to make the dot notation for a certain element, like for example nitrogen N7. Okay, so like making the electron configuration of this one, we're gonna find that 1s2, 2s2, 2b3. So like this here, the outermost energy level is energy level 2, so it has 5 electrons. So in that case, we say that nitrogen is 1, 1, 2, 3, 3, 4, 5. So like that, okay, how to represent, okay, so that the dot notation, which is represented by the nitrogen, or that's here the idea. So regarding to this, okay, guys, we said the electron dot notation also can be used to represent a molecule. That means could represent how the covalent bond is already formed between two different atoms in a molecular compound. So for example, here we said that that's the bond that's formed between the hydrogen. So like this, each one of hydrogen contain one electron. So the two are bonded. They share a pair of electrons. Each one is already sharing by one electron. So here we are going to find the same in fluorine. Fluorine is F9. So the outermost energy level contains 7 electrons. So as we could find that each atom is already have 7 electrons, but they share in a pair of electrons in the middle. Okay, so that's the pair of electrons found between the two F represent the shared electrons. So like this, if we just count each atom, we're gonna find the outermost energy level is completed by 8. So it followed the octet rule, and now it becomes stable. So here we find that in Lewis structure, as we can find here, this Lewis structure, okay, that's which represent the idea to represent the number of electrons in the outermost energy level. So it represents the unshared electrons and the pair or the shared electrons in the same time, and represent that type of the element. So here we can find this pair, okay, of electrons, which is already found between the F, or the two F's. Okay, here the F of course represent the nucleus, represent the fluorine atom. So the two electrons which found between the two fluorine atoms, they represent the shared electron, that which represent the covalent bond. Okay, so here it's a single covalent bond because each atom is just shared by one electron, while the other electrons which surround each F, they are the unshared electrons. Okay, or we call them the lone pairs. So this, okay, yellow ones which is already not between the two F's letter. So like this, we call them the lone pair or the unshared electrons. They are not involved in the covalent bond. Okay, so here we said that the pair of dots represent the shared pair of electrons in a covalent bond is often replaced by a long dash. That means instead of making two pairs in the middle, we could replace them by just a long dash, which represents that is a kind of bond or that covalent bond formed between these two atoms. Okay, the structural formula. Okay, what is structure formula? Structure formula is exactly the same like Lewis structure, but with the difference that in the structure formula we don't represent the unshared or the lone pair electrons. That means we just enough to represent the type of element and the kind of the bond that's formed between them. So like this, we could express the bond between two fluorine atoms like F long dash F, okay, instead of drawing the unpaired or the unshared electrons that surround the fluorine. So here like this, the structure formula indicates the kind, the number of, and the arrangement of the bonds, but it doesn't represent the unshared pairs. The difference between the structure formula and Lewis structure. Let's get an example, guys, to find here. So to find this. So the Lewis structure, okay, and say and the molecular formula, or we said that the structural formula, both of them they could represent, okay, the composition or the molecule which contain different covalent bonds. This covalent bond usually we start by simple thing, which is a single bond in which each atom gonna share by one electron only. So that means the two atoms are sharing in a pair of electrons. That's the single type of covalent bond, but actually we could have more than, okay, that's me. Instead of single covalent bond, may we have double covalent bond, triple covalent bond, based on the number of electrons in which the bond in which each atom share with others. So let's take an example to clarify the idea. He's asked you to draw the Lewis structure of iodylmethane, okay, CH3I. So here like this, we have one carbon atom, 3 hydrogen, and 1 iodine. So like this, regarding to that, first of all, we need to know, okay, how much electron are found in the outermost low energy level of each one of these, or how much the valence electron of each one. So here we're gonna find that carbon already, okay, carbon C6. So that means it has 6 electrons. It has 4 electrons in the outermost energy levels, which means its valence equal 4. It needs more 4 electrons to reach the octet rule. Hydrogen just has 1 electron, but it just needs another one to be completely filled like helium. Iodine, it has 7 electrons in the outermost energy level, so it just need to share with 1 electron to follow the octet rule. Okay, so here we said determine the type and the number of atoms. Okay, so here we find that carbon in group 14, so that means it have 4 valence electron. Iodine is 7, okay, so it has group 17, so it has 7 valence electrons, and hydrogen in group 1, so it has just 1 valence electron. So carbon has 4, okay, iodine 7, and hydrogen has 1, as we said. So carbon just need another 4, iodine just need another 1 to reach the octet rule, hydrogen just need a 1 to be like helium. So what will happen here in that case? Okay, we are gonna find, so carbon needs 4, hydrogen just need 1, okay, and that. So we're gonna find that we have 14 dots, they are gonna be drawn. So simply we're gonna find the carbon which made the 4, so it will make 1 single covalent bond with iodine and the 3 single covalent bonds with hydrogen, as you can observe here. So in another way it could be expressed like this way, guys. I think it's easy. Let's take another example to clarify or just to make this idea. Let's try to answer this one more time to show it in you in another steps. So here, look at me carefully, guys. We say ask you to draw the Lewis structure for CH3I. So simple of all, we're gonna find that carbon is bonded with 3 hydrogen and 1 iodine. So first of all, we need to know how much electron in the outermost. We need to make the dot the electron dot notation for each one. So carbon in group 14, so it means have 4 valence electrons. So we're gonna find its outermost energy level is represented like this. Hydrogen in group 1, so it has 1 dot only. So we have 3 hydrogens, so we have 3 of them like that. Okay. And then iodine, it's in group 17, so it has 7 electrons in the outermost energy level. So it has, so like this. The question is how they could bond it together to be stable. So to be stable, we're gonna find that carbon just need to make 1, 2, 3. We need another 4 electrons. Hydrogen just need 1 electron, and iodine just need 1 electron. So if like that, we are gonna find that carbon simply or will make a covalent single covalent bond with each hydrogen and another single covalent bond with iodine. So in that case, each one of these elements are gonna be like this, okay, stable. So we're gonna find the carbon in the center, okay, and then they are gonna share with hydrogen, okay, with, so we're gonna find that hydrogen, so okay, hydrogen, and here also that was hydrogen. So like this, if we just count the hydrogen, each hydrogen now has 2, 2, 2, and in the same time we're gonna find that carbon now it has 6. So we still iodine already have 7 in the outermost energy level, so it could share with one with the electron. So like this, that each one, if you get compared, so you're gonna find that iodine is already now have 8, carbon 8, each hydrogen 2 like helium, so they all of them are stable. So we could make it like this, okay, that's Lewis structure or structure formula. It could be represented like that, okay. That means we're gonna replace, sorry, that's IV, okay, we're replacing the pair of shared electrons by a long dash, okay. So like this here, that represents the single covalent bond, guys, okay. So we may have more than single covalent bond, we may have double or triple covalent bond, yes, okay. So let's see how it's gonna work, okay. So here we see that a double covalent bond is simply that's a bond that formed between 2 atoms in which each atom is gonna share by 2 electrons. So like this here, they are sharing in 2 pair of electrons. For example, here we're gonna find that's carbon, okay, and the methane, okay, carbon C2H4. So like this, we're gonna find that each carbon gonna bond with 2 hydrogen by single covalent bond, and we still need, okay, the 2 carbons to bond together by a double covalent bond, okay, or that means each carbon will share the other one by a pair of electrons, okay, or 2 electrons. So like this, that's why we form a double covalent bond. A triple covalent bond, it's a kind of bond that forms between 2 atoms in which each one is going to share by 3 electrons, okay, like in case of nitrogen, as we can see here. two nitrogen, they are gonna bond it together. So nitrogen have 5 electrons in the outermost energy level, which means it needs to share by 3 electrons to reach the octet rule. So each nitrogen will share with the other by 3 pairs of electrons, and in that case, it represented by triple covalent bond. So here, like this, guys, we're gonna find here double and triple bonds are referred to as a multiple bonds. Okay, so why we call them multiple bonds? Because it's more than one single bond. Okay, so here we said that in general, double bonds have greater bond energy and are shorter than single bond, and triple are even stronger and shorter than the double bonds. Okay, so like this, as we have more bonds, it means here it's referred to more stability, because beside the normal or the basic that we just at least have one bond. So if we have two, it means more stronger, it requires more energy to quicken, and if we have three, of course, more stronger and need more energy. So that means once the two atoms are bonded by triple covalent bond, they are more stable than they bonded by double covalent bond, more than they are bonded by one or single covalent bond. Okay. So here let's find how we could, that's the steps which we follow to make the Lewis structure. Okay, wait. So first one, gather the information and draw the Lewis structure for each atom. That means make the electron dot notation for each atom alone. Okay. Then arrange the atom, okay, or arrange the Lewis structure to show how the atom they could bond in a molecule. Okay. That's mean we just arrangement to ensure that atoms they try to be stable or they follow the octet rule, except hydrogen, of course they follow the or they try to just to share with one electron only to be like noble gases. Okay, so like this we could find, okay, how it, there are some points here that, for example, halogen and hydrogen atoms often bend to only one another. Okay, that's mean they're just at one end of the molecule. Carbon always is a central or a center molecule. Okay, you will find that the exceptions of carbons and atoms with Lewis electronegativity is often in the central atom. That means always we're gonna find the carbon in the middle. So in most cases, okay. Then we start to distribute or they arrange the electrons around the atom to ensure that they are gonna follow the octet rule. Then we replace the shared electrons. Okay, we replace the shared electrons with a single dash to represent the bonds. Okay. So here, let's see. He's asked you to draw the Lewis structure for the methanol. Okay, or sorry, methanol ch2o, with also known as formaldehyde. So he asked you to draw this. Let's try to do this together, guys. Make it easier, okay? Or start to summarize this guy. So he said that carbon, hydrogen, and oxygen. So actually, carbon we said it's found in group 14. So it has 4 electrons in the outermost energy level. So we find that the electron dot notation of carbon. Hydrogen is in group 1, so it just has 1 electron only, and oxygen is found in group uh, oxygen found in group 16. Okay, guys, so we're gonna find that it has 6 electrons in the outermost energy level. So 1, 2, 3, 4, 5, 6. So that's here the electron notation of each one. So we're gonna find here simply, okay, we have 2 hydrogen, just to remember, okay, because it's CH2O, okay, so like this. So we are gonna find that hydrogen always carbon at the center, okay, and hydrogen will bond with the carbon because hydrogen need to share by 1 electron with the carbon to be stable. So like this, that's how the carbon will look like, okay. So 1 hydrogen is bonded, so that's here the first bond, and the other hydrogen will bond like this, okay. So like this here, the first bond. Then we are gonna find that oxygen has 6 electrons in the outermost energy level, which means it needs to share by pair of electron to complete their outer, or to follow the octet rule. And here carbon still have 2 electrons available, which means, okay, so in that case carbon will share by a pair of electrons with oxygen, okay, like this, okay. So in that case, okay, guys, so in this case, as we can see here, that's how the bond will, okay, look like, or how the Lewis structure will look like, guys. So in this case, we could replace it, okay, to make it another way. So it will be C H H here double bond O. So how many kind of bonds, or how many bonds? Actually, we have 2 single covalent bonds between carbon and hydrogen, and 1 double covalent bond between carbon and oxygen. Okay, so that's how we could make that Lewis structure, okay, of a compound, guys. Okay, so let's check our answer. So here we said that, as we got, we know that here how the carbon look like, and hydrogen and oxygen. Then we said that carbon always okay need 4 electrons, and oxygen just have 6 electrons, okay, and here hydrogen 2 electrons, so overall we have 12 dot must be drawn. Okay, so here we find that the structure will look like, okay, and that's here how it's gonna be represented. Okay, so finally we're gonna find that's how the electron look like, and that's okay. So our answer is true, and that's how to draw the loose structure of a compound. I hope that's very easy, guys. Please study the section very well. Okay, like this we already finished section 2. Please study very well, and if you have any question you can contact me next time, guys.